Okay, in this video, I'm going to continue on with exercise 6b of the book Fundamental Applied Mathematics. We're on page number 162 and the question is 3. It reads, a pendulum is made of a mass at the end of a light string. The pendulum, which is 1 meter long, makes an angle 60 degrees with the vertical when at its greatest height. Find its speed when it is at its lowest point in terms of g. So I've sketched the motion there in front of us. Now, the first thing we need to realize is, as I've said before, you can pick your 0 point of your gravitational field anywhere. All that matters thereafter is your sign convention. So if I choose here to be ugrav is equal to 0, then everything above it is positive and everything below it is negative, which means that the potential energy of at this point here is equal to positive, and a positive number. So I'm going to consider the bob at this point, point 1, and the bob at this point, point 2. Okay, so let's apply the principle of conservation of energy, and we're going to get that the kinetic energy at point 1 plus the potential energy at point 1 is equal to the kinetic energy at point 2 plus the potential energy at point 2. Notice the potential energy at point 2 is positive, so I can need this positive number there, or this positive sign there. Next, let's look at the velocity. We know when the pendulum is at its maximum height, its velocity is equal to 0. For the same reason that your projectile at its maximum height has a velocity of 0. Okay? And let's apply this to the scenario. Next thing we need to do is find the height. So if we know that the length of the bob is 1 meter, then also from here to here is 1 meter. If we apply 1 times the cosine of 60, we're going to find that this is equal to 0.5 meters from here to here. Therefore this is 0.5 meters, clearly. Alright? That means the height is 0.5 meters above the 0 point in the gravitational field. So the kinetic energy at point 1 is a half m times, well that's what we're finding, v squared, plus the potential energy, well I said it's 0, we'll say mg times 0 we'll say, is equal to a half m times 0 squared plus mgh. And we know h is a half, like that. Alright, so we know this is equal to 0 and so is this. So if you have a bit of a physics hat on, you'll see that we're converting all of our kinetic energy into our potential energy by moving up in our gravitational field. And that's of course because we're not taking into account wind resistance and so on. But to a good approximation it means that if you throw your rock into the air, all the kinetic energy you had at the beginning is converted into potential energy when it finishes. So let's just rearrange this, and you're going to find that v is equal to 2mg times a half rooted. So it's equal to mg. Alright? So yeah, mg. It's we give them a mass. We're not give. Oh wait, we can get rid of the m. Sorry, the m is gone. Excuse me. So just going to get the square root of g. All right, which is correct. And let's just see what the answer for that is. The square root of g, 9.81, 3.13 meters per second squared, which is correct. Now, what I'd quickly like to show you is that if you change the 0 point in your field, you'll still get the same answer. So this time I'm going to pick my 0 point of my gravitational field to be at point 2. So let's apply the principle of conservation of energy once more. So I'm going to say K1 plus P1 is equal to K2 plus P2. Noting of course that position 1 is here and position 2 is there. Noting of course also that up here we have potential, positive potential, and here we have negative potential. So let's go. Point 1, half m v squared plus mg. Now, where's h? H is a negative number, okay? So you can either put in negative 0.5, or you could say this is a negative number and just put in a negative straight away, like that, if that makes any sense, is equal to the kinetic energy. Now, the particle is still at rest up here, so it's still going to be a half m0 squared plus mgh. But look, gravitational energy here is 0 as well. So it seems we have nothing over here. How can we be correct? Just bear with it. So this becomes a half mv squared is equal to a half mg. Cancel the m's, cancel the 2's. Right, there, like this. And what do we get? V is equal to the square root of g. Same answer. So I hope that convinces you that you can put your 0 point in your gravitational field anywhere. Thanks for watching. Please pass it on to your friends and subscribe to my channel.